Hello everyone, my name is Anishana and today you are watching Kubernetes video. Just for information that this PowerPoint document can be downloaded from my GitHub page. Beside this, subtitle for different languages such as English, French, Russian and German is available for this video. Let's start with our first session for the Kubernetes. So what is Kubernetes? So Kubernetes is also known as K8s. The first letter is K and then followed by 8 numeric character and then S at the end. So it become K8S. So I hope you will understand the short form of K8S. Let's move forward. So what is Kubernetes? Kubernetes is also known as K8S that I described in the previous slide. It is an open source system for automatically deployment, scaling and management of containerized applications. We can say that K8s is a container orchestration system for automatically deployment, scaling, and management of containerized applications. In simple word, we can say that Kubernetes is to manage the container, whether we use Docker as a runtime or Podman. So now the third topic would be comparison between Docker Swarm and Kubernetes. If we have Docker Swarm, then why we are using Kubernetes? So the main highlight would be Docker Swarm is easy to use and fit with Docker product only, whereas Kubernetes a complete and advanced container orchestration solution. The component will be installed only on master nodes. It means in the operating system of master nodes. Whereas the Kubernetes, all the component will be installed on separate containers on master nodes. And it is possible to have these container on different master nodes. Docker Swarm, quick and easy installation process, whereas Kubernetes it is bit difficult as compared to the Docker Swarm and need to learn Kubernetes. Obviously, one new software we need to learn. Easy to start the cluster for Docker Swarm, whereas in Kubernetes difficult but strong one. Docker Swarm is integrated with Docker CLI, thus limited functionality. On the other side, Kubernetes totally separate CLI, so we can use different container engines. Docker Swarm has a super fast, 5 times faster than K8s. This is the capability. Whereas in Kubernetes, based on the traffic. Docker Swarm, we cannot horizontal auto scale, whereas horizontal scaling can be possible in Kubernetes. So for that reason, Kubernetes is more popular in the market. So history of Kubernetes. In 2003 to 2004, Google introduced the box system. Initially, it was used on small project and then thousands of jobs from different applications work on large scales. In 2014, Google introduced Kubernetes as an open source version of Borg. Kubernetes is a come from the Borg software. You can say that. Google donated the system to the Linux Foundation who work on open source product. In Linux Foundation, there is a sub organization called Cloud Native Computing Foundation, CNCF. CNCF is also responsible for also conducting the CKA and CKAD exams and CKS exams. In 2015, under the supervision of CNCF, Kubernetes was released on July 10 as an open source project under the Apache. Let me move ahead here so that you can see these things. Under the supervision of CNCF, Kubernetes was released on July 10 as an open source. In a basic Kubernetes cluster, at least one master and one worker node should be there to form a cluster. However, in our lab, we will have one master and two worker nodes. We will create containers on worker nodes only and manage these containers through master nodes. VM of physical servers requirement would be minimum requirement of Kubernetes clusters. So in our requirement, we have 3 VMs, right? A compatible Linux host machine, If you allocate less, you will have less room for your application. 2 CPU will be enough. However, if you give more, it would be good. Swap must be disabled. Full connectivity between your clusters, whether it will be in your public or private cloud. Unique host name, MAC address, and so on. Some port must be open. We will discuss later. For this cluster, I will use 20 GB hard disk. So what are the component of Kubernetes? So this question is asking in the interview, and also it would be good to understand all these components. Once you understand all these components, it will be very easy for you to understand the working of Kubernetes. So the very first one is API server, and the second one is scheduler, third is controller, and the fourth is etcd database. However, this etcd database is not the Kubernetes component, it's a third party. But yes, when we're talking about we are using this database, so we and then Kube-Proxy, Kubelet, runtime container, we can use Docker, Podman, whatever we can use, and then pod. So all these components are the Kubernetes components. So what are the master components? So the very first four will be the master Kubernetes components. So all the component will be installed on separate container or master nodes. And it is possible to have these container on different master nodes. So let's suppose that we have three master nodes. So API on master node 1 and scheduler and controller are on master node 2 and etcd database on master node 3 nodes. So yes, we can separate the container. So if my one VM goes down, it won't be impact all my clusters. Whereas the worker node component will be different. So these are the rest of master node is my control plane and worker node is my data plane. So remember in my slide, in my future slides, I will reference that control plane. So control plane means master nodes components. When you deploy a Kubernetes, when we use Kubernetes to manage container, however, in Kubernetes, container is kept inside the pod. Now the question is, what is pod and why it is necessary? So the question is, what is pod? Pod is the smallest, very basic deployment object in Kubernetes. A single process will be used if you're running a pod. In a pod, we can run multiple containers, and these containers will share the pod resources. Pod resources means shared storage, network resources, and specification of how to run the containers. In simple word, we can say that pod is a logical boundary of containers. We assign the IP address to pod, not the containers. Okay, and I will describe how these containers will be communicate with each other. Let's bring back to our main topic, that is master node, that is my control plane, and the worker node, that is my data plane. So this is my master node. You can say that I install the VM, or it is my physical machine that I install the operating system, CentOS 9 operating system, and then install the Docker engine. So this master node is my control plane. And after that, I install the Kubernetes software packages. So when I install these packages, so these four components will be installed. As you can see here that all these three components, that is located at the left hand side of the slide, that is scheduler, controller, and etcd database, they are not talking with each other. They are talking with only API server. So whenever we are launching any command, or whenever we are going to create any container, we just giving the command to our API server. Then API server will do rest of the jobs. I will cover all this architecture today's session. So this is my master nodes. So when I say that worker nodes, so API server will give the command to the kubelet and kubelet will install the pods with the help of Docker engine. And then Kube-Proxy will give the IP addresses. I will explain each and every items very slowly. Okay. So as you can see here that this is my slide. API server is giving the command to the scheduler giving some information, and then it is going through a there, right? But user or in this slide we have the complete picture, whereas kubelet get the instruction from the API server. So let's start with the very first one, that is API. So what is API? API server is the gateway to the Kubernetes cluster. It is the central touch point that is accessed by all the users, automation, and components in the Kubernetes cluster. As you can see here that API server user is giving the instruction to API server, and API server will communicate with other three components. The API server implement as a RESTful API over HTTP, perform all the API operations, and is responsible for storing API object into a persistent storage packet. The Kubernetes API server is relatively simple to manage. Because of the API server's persistent state is stored in the database that is external to the API server. The server itself is a stateless and can be replicated to handle request load and fault tolerance. To elaborate more about stateless protocol does not require server to retain the server information or session detail. Operating the Kubernetes API server involves three core functions. How API manage, how API request will be managed, how request will be processed, and how internal communication will work. So let's illustrate this with the help of diagram. So this is my API server, API manage, API process, and internal communication. This is the core functionality of API server. In API manage, API server is a HTTP server. Thus, every API request must be HTTP request. Before API request can be processed, the client must know how to make a API request, like curl API version 1 namespace, resource name type, and then resource name. Let me move forward here so that you can see the PPT here. How to make an API request, right? User should know. In request process, HTTP request, get, list, post, or delete. These are the requests that a end user can request. And then in request process, your request will be authenticated, authorization, and admission control and special request. So these are the extra four steps will be managed inside this request process. I will cover all these steps in my later slides, but not today because in today's slide you are in very basic. So I'm just go ahead with the functionality of API only, and then internal communication at the end. We will talk about authentication and authorization, admission control, and special request in my later slides, but not for today. It will be enough for you. So let me click here the home button. And from this master component, we have just completed the API server. Let's jump into the scheduler component. In the scheduler, so let's go with the scheduler one. One of the main tasks of the Kubernetes API is to schedule the pod to the worker node by taking care of some condition applied in the pod configuration. That is source, resource requirement, node affinity, anti-affinity rules, apply taint, toleration, and not selector. For the moment, you can ignore these resource requirement. We will talk about in our coming slides. So this work is completed by a dedicated binary component in the Kubernetes cluster called the Kubernetes scheduler. Let's take an example to understand the role of scheduler. Scheduler gets the requirement from the API server to create a pod with 10 GB RAM and 5 CPU. Now, scheduler check all the worker nodes and we have 4 VMs. First rule scheduler execute is filtering the node, that is called predicates. In this case, VM1 has 8 GB RAM, but our requirement is 10 GB RAM. This is the reason scheduler remove the VM1 from its list and keep VM2, 3 and 4. Second rule is ranking of node. We call it priorities. In which worker node I should spawn the pod. One of the important priority function is spreading function inside the ranking of node rule. This function is responsible for prioritizing the node where ports that the member of same Kubernetes services are not present. It is used to ensure reliability since it reduces the chance that a machine fail will disable all the container in that particular service. So in our case, let's suppose VM2 is having Web2 app and Web1 app is from the same service. So in this particular case, it will drop the VM2. So VM now we have only two VM lefts, VM3 and 4. One VM will be selected by random mechanism. So this is the role of scheduler. Let me go back to our control plane and now elaborate controller. Kube controller manager. A controller are control loop non-terminating which regulate the state of system. This work is done by dedicated binaries component in the Kubernetes cluster called control manager. Thus, it manages various controller in Kubernetes, and we will talk about later the different type of controllers. In simple words, in Kubernetes, controller are control loop that watch the state of your cluster, then make changes where needed. Each controller try to make current cluster state closer to the desired state. The controller tell the API to create or remove pods. So actual state should be equal to desired state. Let's suppose that we have configured our 4 container for one application. And here 4 container means 4 pod and 2 pod down due to some problem. Controller control loops check through API, of course, and observe 2 pods are running only. Then it will instruct to the API to create 2 new additional pods. We will learn node controller, replica controller, job controller, deployment controller, and some other topics. For now, you can understand Kube controller prime responsibility is to identifying the current state and make it to the desired state. The controller tell the API server to create or remove pod and controller get all the actual state information from the etcd database through API server. At the end of today's session, I will go through the Kubernetes architecture where you will understand at what stage controller will get the information from the etcd database server. Let me go to control plane again. And now etcd database is the third party component. It is not proprietary to the Kubernetes. So etcd is strongly consistent distributed key value store database. etcd is based on raft algorithm. Raft work by electing a leader among a set of nodes and forcing all write requests to go to the leader only. Changes are then replicated from the leader to other nodes. If the leader goes offline, a new selection will be held and a new leader will be chosen. An etcd cluster always has a single leader node at any given time. elected using the Raft protocol. So how many numbers of etcd database we should have? So ideally, if we have one, we have zero tolerance. Two, we have zero. If we have three, then we will have only one node tolerance. It means that if we have three database etcd node and one goes down, we can recover the data without any failure. And if we have four nodes, again we will have only one node failure tolerance. If we have five nodes, then we can tolerate two node failure. If we have six, so we have only two. So a good rule of thumb is that it only makes sense to use an odd number of etcd node in a cluster as per the Raft algorithm. Let me go back to our main control plane here. So we have successfully completed all the four components. Let me go back to the kubelet here. So in kubelet, we can go to the kubelet. As you can see here that API server is giving the information to the kubelet here. In our lab, we have two VMs, worker node 1 and worker node 2. We have installed the container runtime Docker engine to manage the container. After that, when we install the Kubernetes package, we will observe the kubelet components. It means kubelet is an agent which run on worker node. Secondary use of kubelet is its primary use is to register the node, the API server. Elaborate more. When we attach the worker node with master node, this kubelet is help us. Third use of kubelet is kubelet interact with both the container, runtime and node. As you can see in this PPT, to explain more, how many resources a pod is required, it will get it from the node. The fourth advantage is create, run, destroy pods on the worker nodes based on the pod specs or YAML file received from the API server. The last function is report the stats of pods and node, the API server. After deploy the pod, how many resources node has, it send the information to the API server. In the last slide of kubelet, I have added all the function of kubelet for your references. Let's go back to the data plane of worker node component. Let me go back to the Kube-Proxy. What are the function of Kube-Proxy? Let's elaborate. The Kubernetes network proxy, as known as Kube-Proxy, is a daemon running on each node. This component will also running on every node. What are the function of Kube-Proxy? So Kube-Proxy maintain the network rule on worker node. What IP address is assigned to the pod? As I stated initially, that we are not giving any IP address or we are not assigning any IP address to the container. Instead of that, we are assigning the IP to the pod. And how to reach the pod? This is what we can achieve from the Kube-Proxy. DNS functionality. So when we create these services, those the DNS we will create the DNS record. It will create the DNS record for the services. We will elaborate in the coming slides. Obviously not for today. How to manage the network rules? This is also done by the Kube-Proxy. So there are three types of network rules. One is IP table by default mode. Second is IPVS. And the third one is user space. Legacy mode not recommended anymore. So IP table rules are read sequentially. Thus, if we have many rules are created, then it would be recommended to use IPVS. This is what I have written in the last line here. So let's go back to our next. So in this slide, we will going to learn how it works sequentially. So let's suppose this is my user it asks the API server to create one pod. The API server send the request to the controller node that that one request is received from the user to create one new pod. It says that okay, the desired state is one new pod, so one pod need to be create API. So we can create one pod, and API server will send the request to a scheduler in which pod, in which worker node I should spawn the pod. It says worker node 1, and this is my worker node 1. Then API server will send the request to the kubelet of worker node 1. Kubelet will ask Docker engine to create the pod. It will create the pod, and once it create, it send the response to the kubelet. Yes, the container is created. Then kubelet give all the information to the API server. Then API server again asks to Kube-Proxy to create the network. It says network created. All this information is given to the etcd database server. In next, when again user send the request that I want to create another port, it will again check the controller, and controller will fetch all these details from the etcd database server that if this port is already created or not. Once it validate, it will say that okay again. Please like and subscribe to my channel and press the bell icon to get new updates.